In this video, we will be seeing what are the different operations we can perform on matrices in MATLAB. That is how we can manipulate the matrix, how we can add or delete a column or a row, and how we can generate a matrix in MATLAB. So here, first we'll see how we can enter the matrix in MATLAB. So the matrix is entered row wise with consecutive elements of a row. It means that you have to enter the elements of the rows first. Okay, suppose I am entering the elements of the first row. The elements must be separated by a space or a comma. You can put a space or you can put a comma in between the elements. Now when you enter the elements of the first row and you want to go to the second row, you have to put a semicolon. So the rows are separated by a semicolon in the MATLAB, and these all you have to enclose within the square brackets. Now the elements may be real numbers, complex numbers, or valid MATLAB expressions. So suppose I want to display this matrix in the command window. Okay, so here I want to display this as the output. What I have to type? I have to type it as A in the editor window. I have to type it as A is equal to square bracket, opening square bracket, 1 space 2 space 5. This will be my first row. Now I want to go to the second row, so I have to put a semicolon. Then I have to enter the elements of the second row separated by the space or a comma. Next, if I want this matrix, then I have to type it as B is equal to opening bracket 2 space 2 plus 3i. So this was the first row. Then the first row should be separated by a second row by a semicolon. Put a semicolon. Now type the second row element separated by the space or the or the comma. Next we have a vectors and the scalars. These are the special cases. So here the vectors are the special case of a matrix which will have only one row or one column. That is, you will be having a row vector or a column vector. So here suppose A is equal to opening bracket 1 space 2 space 5. It will produce a row vector. That is, you will be having only one row. You can have as many as columns here. Next, if you have B is equal to opening bracket 1 semicolon 2 semicolon 5 and closing bracket, it will produce a column vector with one single column and 3 rows. Okay, 1, 2 and 3 rows. Here you can have as many as rows, but you will be having only one column. Next, we want to find out the transpose of a matrix. So transpose of a matrix can be obtained by using this command here. A is equal to 2, 3, 6, 7. This is the matrix and we want to find out the transpose of this. You can write it as B is equal to A inverted comma. Okay, single inverted comma, which will give the transpose. That is, B is equal to, here the row will become the column and the second row will become the second column, or you can write it as the first column becomes the first row and the second column becomes the second row. This is how you get the transpose. Next is how you can add a row. That is how you can append a row, okay, or a column. For that, the row or the column, these can be appended to existing matrix. Okay, appending is, that is, you can add at the end. Okay, so here add at the end row as an end row or as an end column. Okay, not in between. So here it can be appended to existing matrix provided the row has the same length as the length of the existing matrix. So the row which you are adding to the existing matrix, it should match the length of that, and the same applies for the column also. That is, the size of the column vector which you are appending to the existing matrix must be of same length. So the command is to add a row. The command is A1 is equal to opening bracket A semicolon and the row vector. Okay, this is the new vector which will be formed after appending the row. So you have to type the variable which you have assigned for the matrix to which you want to append, that is the existing matrix, semicolon and the row matrix or the row vector. Okay. So next, for the column, it will be, suppose we are getting the new matrix as A2, the existing matrix space the column vector. This is the row vector, this is the column vector. Okay, when you want to add the row, you have to put a semicolon. When you want to add a column, you need not to put a semicolon, you have to just put a space here. And here this will be a row vector, and here this will be a column vector. Because you want to add a column, it must be a column vector. Here you want to add a row, it must be a row vector. Now if you have any null matrix, that is if you have any empty matrix, you can add a row or a column of any size. There is no restriction on the size of the row or the column which can be appended to a empty or a null matrix. Suppose this is the matrix I have. A is equal to 1 0 0 0 1 0 0 0 1, which is a 3 cross 3 matrix. And I have a row vector u is equal to 5 6 7 and a column vector v is equal to 2 3 4. If you see, the length of this row is same as the length of the rows present in this existing matrix, and the length of the column, it is also same as that of the length of the column in this existing matrix. Now I can append this row or column to this existing matrix. So I will use this command to append the column. Okay, you are using a semicolon, and along with the row vector, it means that you are appending a row vector here to this column, to this existing matrix. Okay, so you get this as 5 6 7 is being appended at the last. Here you can see this was the existing matrix, and this is the row which we have appended. So here earlier we were having 3 cross 3 matrix. Now we are having 4 cross 3 matrix. One extra row has been added. Now we want to add a column. Here we have to put a space and a column vector. So we will get this type of matrix. Here we have 3 rows and 4 columns. Earlier we were having 3 columns, but here we have added one extra column. So now A2 has become 3 rows and 4 column matrix, that is 3 cross 4 matrix. Now here I want to add a column where I was having the row matrix. I will find out the transpose of the row matrix and I will append that as a column. So A3 will be A space U inverted comma. Okay, inverted single comma. So here now we have got the transpose of the row which has become a column here, and that has been appended to the existing matrix. Okay, so it has become a 3 cross 4 matrix, that is 3 rows and 4 columns. Now suppose you have A4 is equal to A space U. Now this will give you an error. Why? Because here it is a space. No, space means it here we are adding a column vector, but actually our U is a row vector. We have not converted that to column vector. So here it will give us an error. Now suppose you have an empty vector B is equal to like this. You have an empty vector or the null matrix, empty matrix or the null matrix. Now we want to create a matrix which must have some elements in that. So what we'll do is B is equal to opening square bracket B semicolon. I want to add the elements as 1 2 3. So it will produce B is equal to 1 2 3. Okay, earlier it was a null matrix. Now it has some elements. Here in this example we have used a for loop where we have a empty matrix. B is equal to empty matrix. We are taking the range of values of k from 1 to 3. That is the value of k will change from k is equal to 1, then k is equal to 2 and k is equal to 3, and we'll get a matrix here. Okay, so here the elements must be k, k plus 1, k plus 2. These are incrementing, and then we'll end it. So the output of this will be this matrix. Okay, we are creating a B matrix. So the first column, sorry, the first row elements must be k, k plus 1, k plus 2. First k is 1. So it will become k is equal to 1, 1 plus 1, 2, 1 plus 2, 3. Next k value will be 2. So 2, 3, 4. 2, 2 plus 1, 3, then 2 plus 2, 4. Similarly, k is equal to 3, we will be getting 3, 4, 5. Okay. Next is creating a random matrix. For that you have these two commands. Okay, same command it is there, but here A is equal to random of 6. Here we are not specifying what must be the elements, just we are writing what must be the order of the matrix which has been created. So here it will create a 6 cross 6 random matrix, and here it will create a 10 cross 1 random matrix. It means here it will create a column vector which will be having 10 rows and it will have 1 column. So here this command, that is the random of 6, it will generate a 6 cross 6 matrix and it will be filled with random numbers, and these numbers will be in the range 0 to 1. And these values, that is the numbers which are ranging between 0 to 1, these are being drawn from a uniform distribution. So here all the numbers will be ranging in between 0 to 1, and mostly these are equal, okay, likely to be equal. Now you want to delete a row or a column. Till now we have seen how we can append a column. Now we'll see how to delete a row or a column. Here the rows or columns can be deleted by setting them to a row or column vector. Okay, so suppose A is equal to this matrix. Okay, we have this matrix. Now I want to delete the second column. What I will do, I will type this command, A round bracket. Here we are not using square bracket, here we are using round bracket. Round bracket colon comma 2 close the bracket, that is equal to empty bracket. Okay, empty square bracket, opening bracket, closing bracket. So you will get this matrix. You can see here we have the first column, we have the third column, second column is being deleted. You can change this, you can change this to 1. If you change this to 1, first column will be deleted. If you change this to 3, third column will be deleted. Okay, now we'll see how to change the how to delete the row. So when you want to delete the row, here you have to type the command as A 2 comma colon, that must be equated to the empty bracket, opening and closing bracket. So here the second row of this matrix is being deleted. First and third row are kept as it is, 1 0 0 0 0 1. Okay, this is how you delete a row. Again you can change this to 1 3. As you change this, the corresponding rows will be deleted. Here we were deleting only one single row, one single column. So here in this example you will get to know how you can delete multiple rows. So this is a matrix of order 3 rows and 5 columns. So this is the command which I am using to delete the rows from third row to third column to fifth column. Okay, I have to type it as A opening round bracket, then colon comma 3 is to 3 colon 5 closing bracket, that must be equated to empty bracket of square, that is opening square bracket, closing square bracket. So you will get this one, that is you will get the first two columns, column 3 to 5, these are being deleted. Okay, and suppose you have U is equal to, you have a row vector. Now I want to delete this last element. How I can delete? I can type it as U 5 is to, that is colon length of U, that is equal to empty bracket. It means that here the elements from fifth column onwards will be deleted. Okay, fifth column element, fifth column onwards. Not only fifth column onwards elements will be deleted. Suppose you have, see like this will get, suppose you have one more, sorry, here your command will be U of 3 is to length of U, and this command is like this, then the elements from third column onwards are deleted, that is 3 4 5 will be deleted. Displayed will be only 1 and 2. Okay, this is about the manipulation of matrices. Here you can see how these all are executed in the MATLAB. Now here I want a 2 cross 3 matrix, that is I want a matrix in which there are 2 rows and 3 columns. I will assign the matrix a variable, that is A. So A is equal to 1 space 2 space 5. Then for the next row I have to put a semicolon. Then 3 space 9 space 0 and complete the bracket. That is the closing bracket, square bracket. Okay. Now run. So when you run this, you are getting this matrix. That is, this is the output which we are getting in the command window. First row is 1 2 5 and the second row is 3 9 0. Therefore it is a 2 cross 3 matrix, that is there are 2 rows here and 3 columns. Now I'll put a semicolon to this so that it does not display it doesn't get displayed in the command window, I'll go for the second matrix. Suppose I want a matrix B where I'm taking the complex numbers. So here again opening bracket, that is a square bracket, 2 space 2 plus 3i, fine, then put a semicolon, then 3i space 5 plus 2i, close the square bracket. Okay, here I am taking some complex numbers. Now here this will create a matrix which is 2 cross 2. There are two rows, first row and the second row, and there are two columns. So run it. What we are getting here? We are getting it as 2.000 plus 0.000i. Okay, that is here we don't have any imaginary term with the first number, that is 2. Then next is 2 plus 3i. Then you have 3i plus 3i. Okay, there is no real number here, so we are getting it as 0 plus 3i. Then you have 5 plus 2i. Okay, now next here I'll clear this. I will type here CLC so that the command window gets cleared. Okay, now here I'll type CLEAR clear, sorry, CLEAR clear all, run. Okay, here the workspace gets deleted here, sorry, it gets cleared. Now CLC, okay, run. So here the command window gets cleared. Now next I want to I want to create a row vector. Okay, row vector means I want a matrix in which there is only one row. There can be as many as columns. So for that, suppose I'll take again a matrix A is equal to, okay, then you have a opening square bracket, 1 space 2 space 5 space 6. Okay, so here this will create a row matrix. Run it. So here you can see it is creating a row matrix or a row vector. So here you have how many columns? 1 2 3 4 columns. Fine. Now next I'll put a semicolon here so that the output gets suppressed in the command window. Next I want to take matrix B. So here I want to create a column vector. So what I will do, opening bracket, 1 colon, okay, that is semicolon, 2 semicolon, then 3 semicolon 4, closing bracket, okay, closing square bracket. Now run it. So what you are getting? You are getting a column vector, that is it is having 4 rows. It can have as many as number of rows as you put here, and it will be having only one column. So this was about the row vector and the column vector. Now I want to produce a transpose of the matrix. Okay, suppose I will take A is equal to 2 space 3, then semicolon, 6 space 7, and close the bracket. Okay, now I'll run it. What I will get? It will create a matrix of 2 cross 2. That is first row, second row, first column, second column. There are 2 rows and there are 2 columns. Now I want to find out the transpose of this. For transpose, I will take another variable. I'll take B. B is equal to A transpose. So A, and here you have to put a comma. Okay, that is inverted comma here, inverted single comma. Fine, that is apostrophe S here. Now run it. So what you are getting? See here, here A was what? A here was 2 3 6 7. Now B is equal to A transpose. The rows gets converted into columns and the columns will become the rows. So 2 3 has become, this is 2 3 row, it has become now column, and 6 7 was the second row, now it has become the second column. So this was about the transpose of the matrix. Now next what we want to do is we want to append a row or a column to a matrix. Okay, we want to append a row or a column to the matrix. For that what we will do is first we will take a row. Okay, first I'll create a matrix here. Suppose A is equal to I'll create a 3 cross 3 matrix, identity matrix. 1 space 0 space 0, then put a semicolon, then 0 space 1 space 0, put a semicolon, 0 space 0 space 1. Okay, so here if you run it, you will get a 3 cross 3 identity matrix. Now next I want to append a row to this. So if I want to append a row to this, then I have to create a row matrix. Okay, so now suppose I take a matrix U, okay, which will be a row vector that is equal to, I'll take the elements as 5, 6, 7. Then close the bracket. Okay, so now what is the command to append a row? To append a row, the command is, now the new matrix which will be created after appending the row to the A matrix is, I'll take it as A1. A1 is equal to opening bracket, square bracket, then capital A, to which I want to append the row. Okay, then semicolon and U, that is the row matrix or the row vector. Now close the bracket, run it. So here you can see that this was our original matrix 1 0 0 0 1 0 0 0 1, to which I have appended a row, that is 5 6 7. Okay, the length of the row, it should be same as that of the matrix to which I want to append this row. Fine. So this is how you append a row. Now I want to append a column. So for that I have to create a column matrix. Okay, so here to append a column matrix, what I have to do? First I have to create a column, that is column vector. I will create a column vector V. V is equal to what? 2 semicolon 3 semicolon 4. Okay, close the bracket. Now what is the command for appending a column to a given matrix? It is I'll take the matrix which will be created after appending the column as A2. A2 is equal to opening square bracket, then capital A space V, close the bracket. Now run it. So here you can see in the command window the output is being displayed. Here you are getting a 3 cross 3 matrix along with the column which is appended to it, which becomes a 3 cross 4 matrix. Okay, and the length of the here again the length of the this column, it should be equal to the length of the columns which is present in the original matrix. Okay, so here this is the command. Okay, sorry, this is the command for appending a row and this is the command for appending a column. For appending a row, it will be you have to put a semicolon in between and then you have to append a row vector. And for column vector, that is if you want to append a column, for that you have to you need not to put any semicolon here, just space and the column vector. Okay, this was about appending the row. Now one more case I'll show you here. Sorry, I'll delete this. Now suppose I have a null vector b is equal to, that is the empty vector. Okay, now to this empty vector you can append a row or a column of any size. Okay, that is in the previous one which I have shown you, it was a 3 cross 3 matrix. There the column, the size of the row and the column must match with the size of the column and the row of the original matrix. But if you have a null matrix, that is an empty matrix, then you can add a row or a column of any size. So here I will take the matrix as C, which is to be displayed. So C is equal to opening square bracket, then capital B, that is the null matrix, then put a semicolon. Now add the elements of the row 1, 2, 3, close the bracket. So now run it. So here you can see a new matrix has been created, a new row matrix has been created, that is C is equal to 1, 2, 3. Okay, B was what? B was null matrix. To this null matrix, there is no condition that the size of the row should be this much or it should be 4, 3 like that. You can append a row matrix of any size to the null matrix. Fine. Now we will see another example. So suppose here I have B is equal to null matrix. Now I will use a for loop here for K. Okay, K is equal to 1, 2, 3. That is K will take the value as 1, 2 and 3. So the value varies from 1 to 3. Now next I want to create a B matrix. B is equal to, it should be matrix B, that must be appended by K, then K plus 1 space K plus 2, close the bracket and end. Now we'll see what type of matrix it will create. So run. You can see here B is a null matrix. To this null matrix you are appending a row and the value of the row is K, K plus 1, K plus 2. First the value of K will be 1. So it will take 1. Here you are getting 1. Then K plus 1, that is 1 plus 1, 2. K plus 2, 1 plus 2, 3. Similarly for the next one, the value of K will be 2. So it will be 2, 3, 4. Then next the value of K will be 3. So it will be 3, 4, 5. Okay. So this was about appending the rows and the columns. Now we will see how to delete a row. Okay, how to delete a row. Now here we have seen how to add a row, that is how to append a row, how to append a column. We'll see how to delete a row and how to delete a column here. So here suppose I will take a matrix A again, which is a identity matrix, okay, of 3 cross 3 order, 1 space 0 space 0 semicolon, then 0 space 1 space 0 semicolon, and you have 0 space 0 space 1, close the bracket. Okay, run it. So it is creating a matrix, that is the identity matrix of 3 cross 3. Now I want to delete the second row. Okay, I want to delete this second column. Sorry, I want to delete the second column. If I want to delete the second column, I should write the command as A, that is the given matrix which we have taken, then round bracket, opening round bracket, then colon. Okay, it is not semicolon, it is colon, comma, 2, then close the round bracket, is equal to null matrix. Okay, now run it. So you can see here the second column, it is being deleted. Okay, there is first column, there is second column. Second column was there is third column. Second column was what? It was 0, 1, 0, which is being deleted. Okay, if you put here 1, suppose if you put here 1, the first column will be deleted. Run. You can see here the first column is deleted, that is 1, 0, 0 was there, no, first column, that is being deleted. This is how you delete the column. Now I want to delete the row. Okay, so here this is our matrix. I want to delete the row. If we want to delete the row, then again the matrix variable which we have taken, that is A, opening round bracket, 2, comma, colon, close the round bracket, is equal to, equated to the null matrix. Now we'll run it. So here you can see the second column is being, the second row is being deleted. Second row was what? It was 0 1 0. So what we are getting here? We are getting here 0 0 1. Okay, 0 1 0 row is being deleted here. That is the second row. Now I want to delete the first row. What is my first row? 1 0 0 is the first row. I want to delete that. Right here 1. Now run. So here the first row, that was 1 0 0, it is being deleted. We are getting the second and the third rows. Okay, this is how we delete the particular row or a column. Now I want to clear the workspace. I want to clear the command window. CLEAR, clear all. Now run. Okay, here all the workspace, it is being deleted, and even the command window is being deleted. So the elements, I'll close this. Now suppose I have a matrix A. Okay, I have here 5 columns and 3 rows. 1 space, 2 space, 3 space, 4 space, 5. Now for the second column, I'll take it as second row, 2 space, 3 space, 4 space, 5 space, 6 semicolon. Next I'll start from 3 space, 4 space, 5, 6 and 7. Okay, so I'll run it. First I'll run and see whether I'll get correct or no. So here I'm getting 5 columns, okay, and I'm getting 3 rows. Now suppose I want only the last 3 columns. I don't want the first 2 columns. So how I can do it is, A, that is the variable which you have assigned to the matrix, opening round bracket, colon, comma, okay, 3 is to 5. That is 3 colon 5, close the bracket, equal to empty bracket. Okay, or the empty matrix. Now this 3 to 5, 3 is to 5 means it will display only the columns from 3 onwards to 5. 3, 4, 5. First 2 columns will be deleted. We'll see this. It will keep the first 2 columns and the last 3 to 5 columns are deleted. Okay. So here what we want? Here we got only first and the second column, whereas third, fourth, fifth column is been deleted. Okay, so this is how you delete more than 1 columns. Fine. Now suppose I want to delete from second column, second, third, fourth column, second, third, fourth and fifth column I want to delete. Run. So you are getting only 1 column, remaining all columns from second column to fifth column are being deleted. You are getting only the first column. Okay, this is how you delete the multiple columns from a matrix. Now next, one more command we'll see here. Suppose I have U is equal to a row vector, that is 1 space, 2 space, 3 space, 4 space, 5. Fine. Now run this. You will get, this is a row vector of length 5. 1, 2, 3, 4, 5. Okay. Now here if I want to delete a particular column element in this, then what I can do is U, opening bracket, that is a round bracket. I want to delete the element in the fifth column. So 5, okay, is to then LENGTH, that is the length of what? Length of U. Okay, then close this round bracket, equate it to the empty bracket. Okay, now we will see what we'll get. So here you can see we are getting the elements from 1, 2, 3, 4 and the last element is being deleted. Okay, so here the last element is being deleted. Now I'll change this 5 to 3. We'll see what we'll get. 5 to 3. If I do this, then run. What you are getting? You are getting 1 and 2. It means the last 3 elements from the third column are being deleted. Okay, so here it is selecting the elements from the third column, and it will delete all the elements from this third column onwards. Now if I change this to 2, we'll see what happens. So we are getting only 1. It means it will delete all the elements which are starting from the second column onwards. Okay. Now one more thing I'll show you here, how to create a random matrix. Okay, random matrix. Suppose here we'll take a matrix A. A is equal to, the command is RAND. It is random. Okay, random of 6 or random of 4. I'll take 4. Okay, so here I'll run it. See, here you are getting a matrix of 4 rows and 4 columns. But here we have not specified any elements. What should be the element? So here whenever you are using this random variable, here the values of these, or the value for the particular element, it will be drawn from a uniform distribution, and the range of the numbers here, the range of the elements will lie in between the range 0 to 1. Okay, now one more example I'll show you here. Suppose I will take u is equal to random of, I want 10 rows and 1 column. Run. See here. Okay, I'm getting only 1 column. Okay, I'm getting 1 column here. You can see here, and there are 10 rows, and the values are ranging in between what? In between 0 to 1. Okay.